Hello. I gave you a sample exam and I want to solve two questions which one of you asked me to solve or to discuss. And the first one is 9 here, which is if mem2reg is set to 1, which of the following four commands will work? Now, not to give away the solution, but I'll give away the solution because I already did. And the solution is everything, look at 9 here, L, W, S, W, and B, Q, everything except R type. So let's see why that's the case. So let's go to the diagram. This is your friend, this diagram. He's going to solve all your questions. And what do we see? Wait a second, let me get rid of this menu. Hide floating meeting control. Okay. So mem2 register is what we're talking about. That's this one. Mem2 register is this one. It basically decides if you're going to be the read data is going to go get written over here to write data. There's the data from memory that we read, is that should be the one that gets written to the register? Or should the result of the addition be the one that gets written to a register? Now, first of all, we know that in an R type, well, in an R type, we always add two registers and write to a third. So it's always going to be this, like an addition. It's always going to be the sum of this that gets written. So that means it has to be 0 here for an R type. But we said in the question that it's set to 1 permanently. Well, then an R type won't work. Now we have to investigate a BEQ. A BEQ is pretty simple. BEQ, we know that it doesn't write anything to a register. It just changes the PC register, but that's over here. It doesn't write anything to the register file. Here it says registers. That's the register file. It doesn't write anything to the register file. It just writes to the PC because all it has to do with BEQ is change the PC or not change it. So there's nothing, it's not going to matter what we put over here and write over here because it's actually going to be reg write is going to be set to 0. There's going to be no writing going on. So that takes care of the BEQ. What about the load word and the store word? Well, the load word, what does load word mean? It means load it into a register. So we are going to write to a register. What register? Well, we're going to calculate the register. And then that's what the ALU is going to do. The ALU is going to calculate which register, which place in memory we want to read from. It's a load word. And that number is going to go in here, and the outcome is going to be the thing we want to write to a register. Because it's a load word, we're writing to register. So then it has to be a 1 here. Well, that's what it is set to in the question. It says 1. So it's going to come over here and be set because it's a 1 over here. Now, what about a store word? A store word doesn't write anything to a register. It just writes to memory. It stores it in memory. So there's no writing going on here. So it really doesn't matter what comes on this line. So therefore, if it's set to 1, it's not going to be a problem because it doesn't matter. This again, reg write will be set to 0. So that's it. Basically, the only one that needs a 1 over here, that needs a 1, is load word. And all the but and the only one that needs a 0 here is an R type. So if it's set permanently to 1, then the R type's not going to work. So the question was, if we go back, no, I got it. Back to that's the question. Yeah, here's the question. Question was, which of the following commands will work? Well, the R type won't work, but all the other ones will work because BQ doesn't care. He's not writing anything. And store word doesn't care. He's not writing anything to a register. He's writing to memory. Only load word is writing to a register, and therefore he won't work because he's writing the wrong data to the register. I mean, sorry, he will work. I'm sorry, I'm saying it so many times that I'm getting myself confused. The R type will not work. All the other ones will work. The load word will work because it's set to 1, and 1 means write what you read from memory. The R type needs a 0 over there because it's not what you read from memory. Now, the other question that somebody had a question with, which was 11, relate to the following diagram, and then it says, given that, just a second. Yeah, oh, here, I'll move this over here. Given that A is, maybe I can annotate, let's see. Here's the annotate. So it says like this, given that A is 1, let's put a 1 over here, and B is 1, and A invert is 0, B invert is 1, and Cn is 0, so 0 over here, and operation is 2, what will C out be? I'm going to draw a question mark. Question mark there. What will C out be? What will result be? Okay, so this should be easy because if this is a 0, so then the output, this 1 is going to come over here and you get a 1 over here. And this 1 is going to come down into the plus. It's also going to go to the other things, but since the operation is set to 2, we only care about the plus. That's what's going to be ending up going into the result. We have a 1 over here, but now this is a 1 over here on this control line, so it's going to take this value, which is B inverted, which is 0. So we're getting a 0 over here. 0 plus 1 plus 0 is like 1, because 0 plus 1 plus 0 is 1. So the result coming out here will be 1. Now, carry out is asking, what is the number that goes to the next column? Remember, when you add numbers, sometimes the number goes to the next column. You add 9 and 2 in regular math, you're going to get a number going to the next column. It's going to be 11, so there'll be a 1 going to the next column. If you add 9 and 4, you're going to get 13. So you get a 3 in the original column, but there'll be a 1 carrying over to the next column. So carry out is what carries over into the next column. So since the result is 0, 1, right, we said the result is 0, 1. Now that's 0, 1, that's the number 1, right? That's how you write the number 1, 0, 1. Now, so the 1 will come out over here, and what goes to the next column, which is this digit, is going to be, I didn't draw that. Whatever. It's supposed to be an arrow. Okay, that 0 will be the carry out because it's what's in the next column. So that's pretty simple. I mean, I understand it's new to you, but that's just following what this flow shows. Now, we have another question. Can I get rid of these adaptations? There should be a marker. Oh, maybe just Control Z. All right. I'll just do like that. Control Z. No, not letting me. Oh, there's an eraser. I don't see the eraser. Okay, well. All right, I don't see how to erase it right now. Let's go here to B. Given that A is 1, wait, let me stop the video. I'll make a new video. Okay, now we have a cleared diagram, and we're going to annotate again. And we want to do the second question. Note that it says A is 1, and B is 1, and A invert is 0. And B invert is 1. B invert is 1. This looks like the same as we had before, right? A and B are both 1. 0 and 1. C in is 0. That's the way it was before. Operation is 1. So operation is 1. What will the result be? This is tricky here. Well, this is a 0. There's a 1 coming in through here. The 0 means let the 1 in and not the inverted 1. So those will come over here, and you'll have a 0 over here. Sorry, not a 0. My mistake. You'll have a 1 over here. You're just going to see the 0 here. But the 0 is just saying which floodgate to open. We're opening this floodgate, so therefore the 1 comes through here. And what comes into this other line? Well, here's an invert, so it's going to be the 1, but it gets inverted to be a 0. So this is a 0 over here. Now this is an OR gate. An OR gate says, if one of the inputs is 1, then give me a 1. And since we've chosen OR gate, because that's our operation, we're going to get a 1 over here. Now, what's tricky about this question is that the C out, you can say, how do I convert the C out? There's nothing coming from the OR gate to the C out. But that's not a problem, because the C out is connected to the plus, and the same lines are still coming into this plus. This plus is still there. So the 0, in addition to going, the 1, in addition to going over here, is also going over here. You can't stop it. And the 0 that we selected here comes over here also. And now we have a 0 plus 1 plus 0 is still 1. So we get 1 over here, and what goes into the next column is going to still be a 0. So notice that the result is exactly the same in this case. It doesn't have to be the same. Don't learn from this that every OR is the same as every add. But you do see that in this case, I got the same result. 1 and 0. And that's what's written in the answer. Okay, I hope this was helpful. If you have another question, feel free to ask me.